Hello there, and welcome to this module, Programming Practices and Techniques. And we'll start by looking at session 1, Introduction to Computers. Let's get started. So the objectives to be covered in this session, at the end of this session, participants will be in a position to define a computer system, describe the parts of a computer, explain the computer system, startup process, and list the new technologies in computers. Introduction. Now, a computer can be defined as a system that responds to a set of instructions in a well-defined manner, and the computer system consists of different parts, namely, we have the central processing unit, we have the motherboard, the random access memory, that is the RAM, we have the hard disk, also called hard drive, we have the main cabinet with all the peripheral devices connected to the motherboard, we call that the system unit, and of course, we have the operating system. Types of computers. Now, computers can be classified based on their size and processing power, and the different types of computers are given below. Number one, we have the personal computers, we have the workstations, mini computers, and the supercomputers. Personal computers or microcomputers. Now, these are relatively small as compared to supercomputers and mainframes. Personal computers are inexpensive and designed for individual users. They're used in businesses, homes, and schools for surfing the internet, playing games, listening to music, and so on. And they come in different forms such as desktop computers, we have laptop computers, tablet PCs, personal digital assistants, and so on. Desktop computers. These computers are not portable and they're designed to fit on the desk, and they're much smaller in size, easy to use, and cheap as compared to other types of personal computers or PCs. And they're mostly commonly used in offices, homes, and cyber cafes, and so on. And we have an image here showing you a PC. Laptop computers. Now, laptop computers are lightweight and portable, and the physical size of the laptop is the primary factor that determines the cost of the laptop. So laptops which are smaller in size are known as notebooks. I hope you note the distinction between the laptop and the notebook. We have a picture given there. Tablet PCs. Tablet PCs are similar to notebook PCs and have a touch screen or a pen-enabled interface, and they are very useful and popular for writing notes in the fields of law, education, and medicine. And this type of computers offers mobility to the user who does not have enough space to work with a desktop, laptop, or notebook PC. We have that illustration there. Handheld computers or personal digital assistants. Now, a PDA is also known as a palm-top computer or a pocket PC, and basically these are handheld miniature computers. They are smaller and lighter in weight and can be carried in the pocket, and these devices hold data such as a person's schedules, their notes, appointments, address book, and many more. Although mostly PDAs have been replaced by your mobile phone, which offers similar functionalities. You can see we have a handheld computer given there. We have the picture. Then mobile phones that are integrated with PDA functionalities are called smartphones, and these are pictures of older smartphones. Workstation. Now, a workstation can be defined as a type of computer that is mainly used for technical and scientific applications, desktop publishing, and so on. And they're used by a single person and are connected to a local area network abbreviated as LAN. It has moderate computing power and a high quality graphics capability. Workstations have built-in network support, mass storage devices, and graphical user interfaces, and so on. Mini computers. A mini computer is a multi-user computer, and it supports hundreds of users concurrently. And they're smaller to mainframe computers as far as speed, performance, and storage capacity are concerned. Now, when compared with mainframes, they are less expensive. And we also have the supercomputers. Now, supercomputers are fast computers that execute trillions of instructions per second. Your typical PC executes billions of instructions per second. That is why we are calling this a supercomputer. They're used by applications which require intensive numerical computation, such as weather forecasting, nuclear energy research, oil, gas exploration, and so on. The mainframe is a large computer that can support hundreds of thousands of users at the same time. Various components of the computer system. The different mandatory components of a computer system are as follows. We start by looking at the processor, and it's the main component of your computer which executes all the processes and instructions supplied by the memory unit. We have an illustration of the processor there. Remember, we said it's also called the CPU. And if you think of it like a human, this would be equivalent to your brain. Let's look at the RAM, which stores these processes and instructions. This is the RAM. This is the area that the computer stores all the instructions and processes of the system, and it's actually a volatile kind of memory. By volatile, we mean that in case the computer loses power, all the information stored there actually gets lost. And if you had not stored your information to some permanent medium, then what is going to happen? All that information will be lost. Okay. ROM. ROM is the abbreviation or acronym for read-only memory. ROM is a memory chip which contains the inbuilt programs written to it by the manufacturers, and it is an unvolatile memory. We actually call it firmware in another term. HDD. HDD is the abbreviation for hard disk drive, and basically this is an unvolatile memory because it retains information unless the information itself is deleted or overwritten by you and me, that is the computer users, and it can store large amounts of data. This is called the secondary storage. We have a picture given there. Monitor. The most commonly used output device is the monitor, and it is used to display a variety of information, and we have some more details on monitors in the subsequent slides. Let's look at the different types of monitors, and they are given below. We have the CRT. CRT is the abbreviation for cathode ray tube, and these monitors are square shaped. They are heavy boxes typically placed on the desktop. Now, these are found on older computers. They're not used in modern day computers. Let's move on to the next one. We have the LCD. LCD is the abbreviation for liquid crystal display, and the LCD monitors are flat portable monitors, and they're capable of displaying images with more color and better clarity. The next is the plasma monitor. Now, these ones are less commonly used due to their high operating temperatures, high power consumption, and unfortunately, they have a fixed resolution. Meaning that if you're using your computer for something which requires a change in resolution, like you're playing full screen games and other applications which use full screen, they usually change the resolution. Therefore, this is not a suitable candidate for such. We move on to the next one, which is a touch screen. Touch screen is basically what you have in your smartphone or your tablet. And the touch screen monitors provide a touch sensitive screen, and it allows you to interact directly with the application on the screen. Next, we have the organic light emitting diode monitor, and these ones are much thinner and brighter than the LCD or plasma screens. And the OLED monitors can be placed on transparent surfaces such as glass, allowing the user to see through them when they are not active. And these are being used in the newer TVs. Okay, let's look at your computer's primary input device, the keyboard. Now, the keyboard is one of the most commonly used input devices, and the keyboard converts numbers, letters, and other special characters into digital signals, which the system understands. Let's quickly go through the parts of your keyboard or the various sections of your keyboard. We'll start with the top section here, which is called the function keys, starting from F1 all the way to F12. Below that, this next section is called the alphanumeric keys. It comprises of the numeric keys 1 all the way to 0 and the alphabet, that is Q, W, and all the rest of the letters. This part also has other special keys. We have the tab key, we have the caps lock, we have the shift key, there is the left shift and the right shift. This is the left control key. We have the right control key, the left alt, right alt. Left window key, right window key. We have the largest or longest key on your keyboard, that is the spacebar, and we have the enter key. We also have the arrow keys on your computer. This is the up arrow key, the left, down, and right arrow keys. Then on this side, we have the number pad or the numeric pad. This basically comprises of the numbers. After this, what I'd usually recommend is that when you're buying a laptop, make sure you ensure that it has a full keyboard. It's not a requirement, but basically it's one of those nice extra features that you have when you're looking for in a laptop computer. Okay, we move on. Mouse. A mouse is an input device that controls a pointer, which is displayed on the monitor. You can see what I'm doing here. We have this pointer on my screen, and you notice it changes depending on where your mouse pointer is. And the mouse is used to click and drag objects on the graphical interface as well as to select or activate options. And this is a 3-button mouse. We have the left mouse button, the middle mouse button, and the right mouse button. We have other more advanced mouse which have like other buttons on the side here, especially the gaming mice. We move on. Computer software and its types. Software is a generic term for an organized collection of computer data and instructions. A sequence of instructions is specified to a computer to solve a problem. And these sequence of instructions are written in language which can be comprehended by the computer, and they form the computer program. The program controls the processing of the computer, which performs specifically as the program instructs. There are two types of software. We have the system software and application software. And the system software is given on the left side. We have the device drivers, the operating system. We have server software. This is just an oversight, and we have the utilities in your computer. Application software, we have the business software, the computer games, medical software, military software, photo editing software or graphic software, spreadsheets, word processors, and decision-making software. Now, the computer system boot process. The boot process is how your computer starts up, okay? Let's go through this. Now, in order to boot or start up a computer successfully, its basic input-output system, abbreviated as BIOS, the operating system, and the hardware components must work properly. Failure of one of these three elements will likely result in a failed boot sequence, meaning that your computer didn't start up or won't start up. And the BIOS is a microchip that stores the instructions such as POST. POST is the abbreviation for power on self-test in a predetermined memory address. Now, once the POST determines that all the components are functioning properly and the processor has successfully been initialized, then the basic input-output system looks for the operating system and its boot sequence in the MBR. MBR is the abbreviation for the master boot record. Now, this master boot record shows the BIOS, where to find the OS, as well as the subsequent program files that will initialize the operating system. And after the OS initialization, the files are copied into memory by the BIOS, and the operating system takes control of the boot process. If you're using something like Windows, this is where you see the Windows flag when this process takes over. Okay. We have this CMOS setup utility, and this is a screen that you get to in case your computer is not booting or you want to troubleshoot the boot process. I highly recommend that you don't come to this screen, not unless you really know what you are doing. Okay. We move on. New technologies in computer. We have cloud computing. Now, cloud computing evolved from the concept called virtualization. And using virtualization, you can host multiple operating systems at the same time in a single machine or a single computer. This is where you will load several operating systems or several virtual machines in a single computer. Of course, it must have a very good processor and lots of RAM, because every machine is going to require some RAM from the host computer. Now, a traditional application server may just have 5 to 10% utilization, whereas a virtualized server can reach 50 to 80% utilization. And by hosting more virtualized instances of fewer physical servers, You're able to lower the cost for hardware acquisition, maintenance, energy and cooling system usage. Grid computing. Now, grid computing is defined as an interconnected computer system where machines utilize the same resources collectively for solving a problem or reaching a common goal. Now, grid computing usually consists of one main computer, which distributes information and tasks to a group of network computers to accomplish a common goal. Utility computing, this is where computing resources and infrastructure is provided to the customer by a service provider, and the customer is charged according to the service usage. This behaves like your water bill or electricity bill. The concept is basically the same. The more you use, the more you pay. The less you use, the less you pay. It's a pay-per-use service. Let's look at the details of each of these. Cloud computing. Now, cloud computing is divided into three major cloud structures. We have the public cloud. The public cloud can be accessed by anyone using the internet, and the client manages their normal resources that operate within the cloud and provide appropriate remuneration for the service used. Private cloud, this is a cloud technology which uses a private data center to which only one organization has access, and the organization maintains its own data center and staff, but IT resources within the cloud are available on demand. The next one is a combination of these two. We call it the hybrid cloud, and they are a combination of the private and public cloud. Sometimes an application in a private cloud extends to use resources present in a public cloud. This is usually like for backup purposes, okay? The different types of services provided in cloud computing platform are given below. We have the infrastructure as a service, and in this model, computers and other resources are provided to the users. This is like when you hire a car, okay? So you hire the computers and everything else. Next one is the platform. In this model, the operating system, the program execution environment, database or database, and web server, they're provided as a service. Next is the software as a service. And in this model, the cloud providers install and operate the application software in the cloud, and you access it via the internet. Storage as a service. In this model, large service provider rents out storage infrastructures. This is like what we usually use, like your Google Drive, your Dropbox, and similar services. Security as a service. In this model, large service provider integrates into the corporate infrastructure security services. This is like the way we hire security guards. It's just that now we are hiring a firm to take care of the security of our IT infrastructure. Data as a service. In this model, data is provided to the user as and when required, irrespective of geographic location or organization separation between the provider and the consumer. Test environment as a service. In this model, software and its data are hosted to be accessed and used using a browser over the internet. Then we have the desktop as a service, where in this model, the desktop is actually virtualized. And finally, we have the API as a service. API is the abbreviation for an application programming interface. And these are usually predefined components made up to speed up our development process. Good example is like the way car manufacturers buy ready-made tires to make their work of assembling cars much faster. We move on. Grid computing. Now, advantages of grid computing are, number one, large six-figure symmetric multiprocessing, that is SMP servers for application processing are not required. Idle resources can be utilized much more efficiently by distributing jobs to idle servers or idle desktops. A grid environment has a modular structure and does not have a single point of failure, and systems can be upgraded without scheduling downtime. Jobs are executed in parallel, thus enhancing or speeding the performance. Disadvantages of grid computing are large SMP are still used when applications that require high memory don't take advantage of MPI. A fast connection in between the computer resources is required, that is from one computer to the next one. And some applications are required to be fine-tuned to take full advantage of the new model. That is, you have to ensure that you thread your applications properly so that it takes full advantage of the multiprocessing environment. Then we move on to utility computing. Now, advantages of this is that the client is not required to buy all the hardware, software, and licenses. Instead, the client depends on the utility computing company to provide these services. It gives companies the option to subscribe to a single service and use the same software suite for the entire client organization. Good examples of these could be Office 365, which is provided by Microsoft, or we have the G Suite, which is provided by Google. Okay. Disadvantages of utility computing are if a utility computing company has financial difficulty or has frequent equipment problems, clients could get disconnected from the services even after they have paid for that particular service. And utility computing systems are always targets for hackers. A hacker can access the service without paying. They also sneak around and explore or steal client data and files, which is a serious concern. Okay. And with that, we've come to the end of the session. Let's see what we've learned today. Number one, the computer consists of different parts, namely the CPU, motherboard, RAM, hard disk, the main cabinet or the system unit, with all the peripheral devices connected to the motherboard, and an operating system. A workstation can be defined as a type of computer that is mainly used for technical, scientific applications, desktop publishing, and so on. Booting is the process of loading the operating system when the user switches on the computer system. Cloud computing is an approach enabling convenient and on-demand access through the internet to resources such as networks, servers, storage, applications, and services. Grid computing usually consists of one main computer that distributes information and tasks to a group of network computers to accomplish a common goal. Utility computing is a service provision model, and in this model, the service provider makes computing resources and infrastructure management available to the customers needed and charges them for specific usage rather than a specific rate. With that, we've come to the end of today's session. So have yourselves a nice time and God bless. See you in the next session. Bye.